बनवायची काही गोष्ट पुढे आहे का?
हार्दिकर. Good morning, everyone. I welcome you to this expert lecture on future of power electronics. So let me introduce you to our today's guest speaker. So regarding his professional background, he was assistant professor at Department of Electrical Engineering, NIT Hamirpur. Then he joined Birla Institute of Technology, Mesra, Ranchi from August 2021. His research areas are power electronics interface for non-conventional energy sources, power quality issues, power conversion and management, then control of DC and AC microgrid systems, and grid interactive converters and their control. Again, let me read out some of his honors and awards. So he has MHRD fellowship for PhD. He got it for PhD as well as MTech. Then awarded by Bharat Vikas Parishad, Kaithal, for first position in academic at university level. He also won a gold medal for securing first position in the Department of Electrical and Electronics Engineering, HCTM Technical Campus, Kurukshetra University. He is having more than 16 journal publications and 8 conference publications. Maybe some of them are in line. He's also a member of IEEE. So let's welcome our guest, and let's be, you can say, showered by his knowledge, and hopefully it will help you in your careers. So I hand over to this session to our expert, Dr. Ajay Kumar. Sir, please.
Thank you, sir. Thank you so much for inviting me for this lecture. Good morning, everyone. And today I will discuss about the power electronic and basically application of the power electronics, because you all are like having some basic background knowledge of the power electronic, and you are like, I think, in second year or third year, so you are having a basic knowledge of power electronics. So I just want to convey how the power electronic will be utilized for the power system application, and how different applications are associated with the power electronic. Because when this renewable energy sources, they are like coming into the picture, electric vehicles, that is also like coming into the picture. So because of these, the power electronic and the power electronic devices are like increasing day by day in the distribution end, for the interfacing everywhere. So first let me share my screen. So first of all, what is power electronic? You all know that this power electronic basically deals with the control and the conversion of the high power applications, right? In power electronics, this is like a combination of power and electronics. When you compare this with the signal electronics, you will find that in signal electronics, you will have like application in the range of plus minus 3.3 volt, plus minus 15 volt, plus minus 5 volt, right? But whenever you come to the application related to the power electronics, so the application and the devices and the rating will be like from few kilowatt or few megawatt to like 100 of the megawatts, right? Now the question arises that how to increase the power handling capability of these devices. Suppose you have one PN junction diode. So in case of the signal electronics, you just need one P-type substrate, one N-type substrate, and there will be a junction between these two, P and N layer. But whenever you want to use this particular diode for the power applications, so you have to insert extra drift region, right? That drift region allows you to enhance the voltage handling capability. So the size, or you can say that the length of the drift region, will always decide that how the power handling capability. We need to increase the cross-sectional area. So whenever you are like increasing the cross-sectional area of a particular device, let us say PN device, so then you can say that the current handling capability of that particular device can be increased. You can think like that. This is a normal PN junction diode, P and N. And when you want to utilize this for the power electronics, you just need to insert one extra layer. And that extra layer is basically known as the drift region. So this drift region will decide the power handling capability of that particular device. So in power electronics, you will find that each and every device is associated with the power applications only. That is why the name coined like power electronics. And in signal electronics, the applications are like related with the low power applications only. And these devices, the signal devices, you can say that handles very low power applications at very high switching frequency compared to the power devices. So in signal electronics, the power level will be like lower and the frequency level will be higher. You can take an example of the signal electronics like signal diode, Zener diode, LEDs, vector diode, etc. But same thing will be like applicable when you increase the power rating. They all are like come under the category of the power electronic devices. In fabrication of like, you have to like think this way, that in fabrication of the semiconductor devices, when we improve one quality, the other quality may be affected, right? That means we cannot improve all the qualities in a single device. Likewise, you can say that if you want to increase the power rating, so definitely there will be a compromise. On the other side, if you want to increase the frequency, then definitely there will be a compromise on the power rating. I think if you have gone through the power electronic devices, so you just need to classify, like initially, I think you have gone through power diode, then SCR, then GTO, then power BJT, then MOSFET, and then IGBT. Now, if you compare all these devices, you will find that MOSFET has the highest frequency handling capability. You can say that you can operate the MOSFET at a very high frequency, right? But on the same side, the power handling capability of the MOSFET, or power MOSFET specifically, I am talking about the power MOSFET only, because now onwards, if I am talking about MOSFET, it means it is power MOSFET. If I am talking about IGBT, it is power IGBT. So when you compare all these power electronic devices, so you will find that the MOSFET has the highest switching frequency, but the power handling capability will be lower. On the other hand, the SCR has the highest power handling capability, but the frequency will be like on the lower side. So there will be like a continuous, you can say that one quality will be like increased, other quality will be like decreased, right? And you all know that these are usually used as a switch, or you can say that all the times they will be like utilized as a switch, right? So we can utilize the switch in 4 different modes, and it is not like necessary that all the devices will be like supported each and every mode. Some devices may support 2 modes only, some devices may support 3 modes, some devices may support 4 modes, right? You can take an example of like SCR, right? So SCR is like what? It is like supporting 3 modes. If you are having an idea of all the 4 modes, that means the SCR is particularly supporting the forward blocking mode, because up to a certain level, this SCR forward breakdown region will not break. After that particular voltage, you can say that this breakdown occurs and the device will be like in forward conduction. And there will be another mode for this particular SCR is like reverse blocking. So your SCR is like working in 3 modes. You can take an example of simple diode, power diode. So in case of the power diode or the simple diode, you can say that the diode will be like working only in 2 modes, that is forward conduction. Immediately when you apply the voltage, anode will be like positive, cathode will be like negative. So immediately your device will be turned on, right? Then there will be a forward conduction. And you can also think that whenever you apply the reverse voltage, so there will be a reverse blocking capability, and that will be like, you can say that that mode will be there for that diode. But in SCR is basically a semi-controlled device, right? So because of this semi-control nature, you can say that you can control the device. That is why there will be a forward blocking mode, and then forward conduction, and then reverse blocking. So similarly, you can go for other devices also, like you can take an example of triac. And triac, the beauty of the triac is like that, this is like the only device, or you can say that one of the very few devices that can be utilized in all the 4 modes, correct? This triac is treated as an AC switch generally, right? Because it supports all the 4 modes. So you can say that it can be used in AC voltage controller. This is the application of the triac. You can use this for the AC voltage controller or fan regulators, you can say that. So based on the mode, based on the application, or based on the power and current handling capability, different power electronic devices will be utilized for different applications. Now you can take an example, like suppose if you are going for the application part, you can take an example of mobile charger. All of you are having mobile chargers, laptop chargers. So in the mobile charger, you just have to utilize one rectifier, because first of all, you just need to convert the AC that is coming from the, like your national grid, you just need to convert that into a DC. So AC to DC conversion will be taken care by the rectifier only, right? In power electronics, I think you have gone through 4 kind of the converters: AC to DC, that is rectifier; then DC to AC, that is inverter; then DC to DC, they are like known as the DC to DC converters and the choppers; and then AC to AC, that is voltage controllers, or you can say that the voltage regulators, right? So for 230 volt to the desirable level, because your battery require a certain amount of voltage level, so for that, and that voltage level should be like DC. So for that case, you just need to convert 230 volt AC into DC. Why I have taken this 110 volt and 60 hertz? Because if you want to talk about the universal charger or universal adapter, that means you have to like follow the convention that will be like applicable across the world. Suppose in USA, the supply range for the single phase system will be like 110 volt 60 hertz, right? So for that case, I have considered this. Now your rectifier is like converting the AC into DC, but that DC is like not pure DC. You can say that the output of the rectifier is pulsating in nature. Suppose you have like full single phase bridge rectifier. So in that case, the output will be like, let us say alpha is equal to 0, right? Alpha is like firing angle. So the output will be like 2 Vm by pi. Roughly you can say it is like around 0.9 of the CRMS. But the battery will require a lower voltage, right? The battery will require a lower voltage for charging, right? So you have to connect extra DC to DC converter, right? That DC to DC converter will try to regulate the DC, right? Try to regulate the DC and provide the certain level. That level required by the battery, right? Suppose your battery is like 5-volt battery, so that has like specification that 5.5 and 5.7 voltage will be there. That means the battery is fully charged. And if voltage is like 4.2 volt, that means the battery is fully discharged. So in between these ranges, the voltage across the battery will be there, and accordingly current will be like drawn by the battery. So you will find that there are two stages that will be utilized to charge the battery, and all these two stages are the power electronic stages. First it is rectifier, then it is power electronic converter, that is DC to DC. Now, what are the requirement of this? You can say that the power electronic stage. So, first requirement is this DC to DC converter, or you can say that this power electronic circuit will provide the voltage and the current regulation, right? Voltage and current regulation means whether the voltage is like increasing from 230, or you can say that decreasing from 230 to 110, but the input side of the battery should be maintained at 5 volt or 5.5 volt, right? That voltage will be regulated by this DC to DC converter. So this is like beautiful application of this DC to DC converter. The voltage is regulated, right? And similarly, the current is also like regulated, correct? Another advantage is like isolation. Or you can say that another application or requirement of this power electronic devices is like to provide the isolation. Isolation is very important because sometimes you have one power circuit and on the another side you have one control circuit, right? So control circuit, the rating of the equipment or rating of the devices on the control side will be like very low, and on the power side you are handling a very large power. So there will be like difference in the ratings. Another thing is that if there is any fault that is happening on the power circuit side, right, and if there is no isolation, so that fault and the high amount of the current can flow through the like control part. So that can damage the control circuit also. So my question is, and my like requirement is that we just need to provide an isolation between the power side and the control side. So therefore, these power electronic devices and the extra auxiliary circuits are required to provide the isolation. Isolation is very important to provide the separate ground for control side and power circuit side, right? So these are the two major requirements. You have to vary, you have to regulate voltage and current, and you have to provide the isolation by using the power electronic converters, right? So this way you can say that for maximum applications, you can say that power electronic converters are essential, power electronic interfacing are required, and if you are having power electronic device, you need some knowledge of control, because ultimately you have to control the power electronic device. Whenever you want to operate any power electronic device, you have to provide a pulse, you have to provide a gate pulse, you have to provide a signal, right? So you have to require certain knowledge of the control so that you can control your closed loop, and then you can provide the gate pulse to that particular power converter. Another requirement is like you have some knowledge of sensors. So because whenever you want to operate the control, you need to sense some quantities, that is voltage, current from the load side, from the distribution side, and accordingly your intelligent controller, or you can say that the control algorithm that you have provided inside the controller, that controller will decide the switching pulses, right? So this way you can say that the entire circuit will require a knowledge of control, a knowledge of circuit theory, a knowledge of sensing and like measuring equipments. This is like another example of this power electronic converter. Suppose you want to control the speed of the drive, or you want to control the induction motor that you have connected. So in that case, first you have to use this AC to DC rectifier, right? And rectifier will provide like initially on the AC side you have 50 Hz frequency, and you are going for the V by F control. Whenever you are going for the V by F control, that means you have to control this frequency and you have to vary the frequency. So for that case, first you have to convert AC into DC, and this AC into DC means you just need to utilize the rectifier. So you have utilized this rectifier, right? So here 50 Hz AC is there. Now converted this into DC, and then again inverter is required, and this inverter is basically converting this DC to AC with variable frequency, right? And then you can say that you can control the speed of the induction motor. So again, for this application, the application is like speed control of the induction motor, right? And you can say that you are supplying AC to the induction motor. Then this power electronic medium is required to control the speed of the motor. Correct? So this way you can take so many examples, and each and every example you need power electronic medium. Now another example, suppose you want to take that renewable energy sources, they are connected to the grid with the help of power electronic converters. Suppose you can take an example of solar photovoltaic system. So the solar photovoltaic system is like providing a DC, right? It is like a current source. Solar photovoltaic array, if you are taking, or solar photovoltaic panel you are taking, so that means that is like a current source, right? Giving the DC. So first you have to convert the DC, then you have to integrate to the existing grid, right? So again, power electronic medium is required. And whenever you are like integrating, you just need to control. So control is also required in order to handle the power electronic devices. Similarly, you can take an example of battery charging that is already taken in the last slide. You can take another example of wind energy conversion system. So in that case also you need back-to-back converters. So again, power electronic equipment and power electronic converters are required. So my thinking is that whenever you are going for applications related to the renewables, right, then you need power electronic medium. Essentially, you need power electronic medium. So that is why in this entire lecture, I just want to cover few of the basics of the power electronic converters, and then I will also provide the development and design of the few of the converters, and then how to control these converters for particular applications. So I will explain about this solar PV integration, how the solar PV is basically integrated to the existing grid. Correct? Now, suppose you have knowledge of this power electronic devices and power electronic switches. So now please tell me, can you fire or can you drive a single switch with the help of a single pulse? Just the pulse is coming from controller. See, whenever you are getting a pulse from the controller, because you can take an example of IGBT or MOSFET. So IGBT and MOSFET both are like voltage control device. You all know. Output will have 3 pulses. For 0 to 2 pi period, you will have 3 pulses in the output in the DC. And when you are going for the 6 pulse, you will have 6 pulses output for 0 to 2 pi period. So see the PhD. And this 6 pulse rectifier is like without filtering arrangement and without input reactor. Nothing is there. Directly 6 pulse converter is there. See the TSD. The current waveform will be like completely distorted. Right? There is no use of this kind of the waveform. This waveform is like completely equipped with the harmonics. See the TSD. TSD is like 80%. This is a use. You have to maintain the TSD below 5%, but actually it is like 80%. So this gap is very large gap is there. And see the harmonic content, 5th, 7th, 11th, all the odd harmonics will be there. Next, you can observe this 6 pulse rectifier output voltage filtering with 3%. You can say that the reactor filter or with continuous output current will be there. So in that case, the output waveform will be like, or you can say that the current waveform will be like little bit improved. That is why the TSD will come around the 40%, right? But still the TSD in the higher side, right? And whenever you are using this 6 pulse converter with large inductor, still in that case you will find that 28% TSD is also there, right? Suppose you have highly inductive load, you have considered that. That means you are getting constant output current, but still the current that the rectifier is extracting from